Yeah, you did it. I've never pronounced your last name before, I just realised. So, Kukomaftis? Yeah, pretty good. Lonnie Kukomaftis.
Thank you very much. So before I get started, I'd just like to acknowledge the traditional owners of the AIM site where all this research took place. And I'm going to talk to you about out-of-season spawning and how that can possibly, hopefully, help with reef restoration. So, which button is it? Big one, thanks. Okay, so we should all know that every summer the Great Barrier Reef corals mass spawn, and it's great for reef renewal, but it actually creates a larval supply bottleneck, so we're restricted to those summer months to do any work on larvae. So we've always known that if we could control the reproductive cycle of corals, we could really accelerate that understanding of the early life cycle of corals and advance that work into the biology. So in order to do this, we need to understand, firstly, what governs the reproductive cycle of coral. And this is fairly well known now in the literature, ranging from sea surface temperatures from early late gametogenesis into lunar profiles and photoperiods down to the actual nights of spawning, particularly the period of darkness post sunset and moonrise. So if we can have advanced control over these environmental variables, then we're one step closer to being able to get corals to spawn on cue. So I'm lucky enough to work at the National Sea Simulator at AIMS, where we have the advanced capabilities to control these environmental parameters from temperature, salinity, CO2, moonlight, and photoperiod. So it's really a marine scientist anachorous playground where you can have such advanced control over these areas. So every year we do mass spawning at the sea sim where we collect wild gravid corals, bring them into the aquaria tanks and spawn them on those expected nights after full moon. But we also have a captive ambient breeding program where we keep corals in outdoor aquaria under an ambient temperature profile. This profile is based on the Davies Weather Station 18 years worth of averages, which don't include the most recent bleaching years too. So the advantage is that we're controlling the temperature and we're not exposing these broodstock to those large degree heating weeks, which we've heard about throughout this conference. These are applied daily through a micro programmable logic controller. So we kind of set and forget, and it allows them to synchronize into that seasonal temperature profile. And regularly these captive coral broodstock spawn in synchronization with those wild collected corals. So in terms of developing an offset profile, we simply took this temperature, offset it by 6 months. And so as currently now back at AIMS, these corals are coming into the summer period where we expect some spawning in the next month. Over the last 10 years, this project's been going for a very long time, we started to generate F1 broodstock from those wild collected colonies. From 2014, we started developing F1s across 5 different acro species and 1 Montipora. And once we'd felt we had enough broodstock and they were of expected size or age to be reproductive, we applied that 6-month offset profile in June 2019. Fantastic, within 1 year we had pigmented eggs in 2 of these colonies, a millipora and a hyacinthus, and that was in the winter in June 2020. Unfortunately, we didn't ever see them spawn, and we think what happened is that we weren't providing offset photoperiod or moonlight, so they didn't have those environmental variables, and it's likely that they spawned unobserved, unfortunately. So we added photoperiod and moonlight in 2020, and then we had even more corals synchronise into this profile. So we had 6 corals developing eggs. So we thought we were on the money this time, but unfortunately, again, we didn't see any spawning. And this time when we looked back at the data, it looked like there was some moonlight corruption in the profile in the month, that critical month leading up into spawning. So we didn't give up because we were really stubborn and we want to make this happen. So we really closely checked our environmental variables and kept going. And in 2022, we finally observed the spawning across some colonies. So we had 8 colonies spawn, producing 15,000 larvae. And not only that, we actually managed to fertilise and settle millipora and LCI. So not only are we producing reliable spawning, we were getting successful recruitment. those keen-eyed spawners would recognise that May is not actually offset for the mid-shelf expected spawning time, but this year and this data was a split spawning year. So this is why we had spawning across May and June. So June was even more successful, and we had 38 colonies producing 100,000 larvae, making 8 larval cultures across 4 species, and also settling 4 Acropora species and closing the life cycle, producing F2s in captivity. And then in 2023, we had similar results, except we had 1.3 million larvae produced this time, primarily from the 6 Montipora aquatuberculata, which spawned, so creating a lot of opportunities for work on those larvae. We also closed further life cycle of the Montipora and an Ostera colony. Again, this May 2023, this time it wasn't a split spawning year, but what it was that it was an inshore full moon, and these broodstock, the Montipora and the Ostera, were collected from the Palm Islands, so they were expected to go at this time. And then in June, we also got about 500,000 larvae created from 54 coral colonies. In summary of those 4 spawning events so far, we've had more colonies spawn in 2023 compared to 2022. We think this is because both the colonies are becoming more sexually mature in the system and possibly further synchronising into these offset profiles. So we're getting better as we go along. What's really striking to me is when we analyse the data, the night after full moons are spawning within the predicted times in the literature, and we're using the Baird et al. Spawning database. So even though these corals have never seen the reef, they've never even seen natural sunlight because they've held in captive indoor aquaria, they're still so synchronised into these environmental conditions that we're providing them that they're spawning within that expected range. And the statistics that we've run have shown no significant differences between years and the literature. This is really important if you want to make really good larval cultures with good genetic diversity. You want them all synchronised within similar nights after the full moon. Also, time after sunset, so spawning time was again within the expected literature, and stats showed no significant differences. Now, I'll also add that we have this 6-month offset profile, but it's also 5 hours offset. So we have spawning starting from about 4:30 p.m. For all those people that have done really late night spawning, this is actually fantastic because you make your cultures up, you might check your fertilisation, and you leave by 6:30 in time for dinner to get home. It's brilliant. So what do we do with all this is the main question. We have so far supported 12 separate research programs from internal AIM scientists and externals, ranging from CRISPR-Cas9 work to symbiosis work and settlement work. So what's actually happening is that a lot of these groups are honing their experimental methods and testing a range of metrics that they want to prepare for the summer spawning season. So they're sort of better prepared for that natural spawning event. So we are starting to fast track, hopefully, the understanding of the early life cycle of corals. In terms of future directions, it's all well and good to provide a range of gametes and larvae from species, but we want to make sure that they're physiologically comparable to what you would get from the wild. So we've started doing lipid content of broodstock and eggs, photophysiology on the broodstock, sperm motility, egg size, and time to competency from the larval cultures. We want to boost larval production of key species. We try to align that with what the RAP key selection species are to get up into those millions and maybe tens of millions of larvae on tap. In order to do this, we're going to collect from the wild. We want them to desync from the ambient profiles and synchronise into our offset profiles. Preliminary work shows if you time it right, you can do that within 9 months for acroporas at least. We want to include the auto-spawning systems, which you guys might have heard about throughout the conference, to maximise the larval culturing methods. And the proof of concept has occurred where we know we can offset 6 months. So theoretically, if you had 12 separate rooms, you could have spawning every month. That's a lot of work for the scientists and technicians who might not be so keen on that, but it is a viable option. A question that might be on your minds in terms of restoration, outplanting, and I want to talk about the scale of this and the limitations, is we know that the pilot scale deployments in 2030, there's 20 species across 3 reefs which are planned. if we do crunch some basic numbers, it looks like we'll need one system per species per reef if we want to keep up with that year-round spawning or offer another opportunity to outplant in winter. So it would require quite a lot of infrastructure and staff power to get that as a reality. Genotype requirements is still hotly debated. I just came out of Hughes' talk and he talked about having 30 genotypes to be close representation of the wild population genetic diversity. So in terms of having that in a captive system across all those numbers we're talking about, again, it kind of blows out your price, and long-term captive holding would be quite tricky. And lastly, the production cycle keeping up. This would involve deploying recruits as soon as possible after settlement, which is what RAP are doing currently. Obviously, if we're using recruits from this system, we're going to be deploying them in winter, and we don't quite yet have an understanding of what the impacts on acclimation and survival and growth would be of deploying corals from a summer temperature profile into the ambient winter. I'd just like to thank everyone for listening to the talk and acknowledge the entire CSIM team. So it definitely takes contributions from every single team member at CSIM to make this project a reality. And the AIMS communication team and Andrew Negri for his expert spawning advice. Thank you.
Awesome stuff. Do we have any questions for Lonnie? Plenty of questions for Lonnie.
Thank you. That's very interesting and exciting. When you're talking about using this broodstock to outplant, do you have a plan for sort of gradually raising the temperature they experience? Because if they're sort of being maintained at these 0-degree heating weeks for spawning, what's your plan for that?
Yeah, that's a fantastic question. There's no current plan, I'll just be clear, to use the larvae for outplanting. It's an opportunity primarily now for method development. Obviously, if there were discussions within AIMS RAP to use this stock, we would definitely want to build in some kind of resilience to the thermal stress that they would experience when they went out there. The last thing you want is you to outplant all these larvae in winter and then a bleaching event comes along and wipes them out. So yes, definitely something that would be involved in the discussions. Thank you.
You mentioned having 12 rooms with 12 different offset corals. Could we have 6 rooms that the corals are capable of spawning twice a year, every 6 months? Can we reduce that time window down?
Yeah, that's another great idea. And I know there's work, Jamie Craig's in particular, who has coral colonies that are spawning twice a year. That would involve, we would just take our offset profile and condense it to 6 months. But currently I'd like to do some prep work in the broodstock, so part of the gamete physiology, and make sure that the broodstock are in best health before we kind of push them to spawn every 6 months. So I would prefer to add an extra room, although it would be more costly. So yeah, definitely we've had this discussion and had to think about trying to push our corals as far. Yeah, good idea.
Hey, Lonnie.
Hey.
My head hurts a little bit. It often does. So you've changed the temperature and now the temperature cycle, which has put these corals in line with Ningaloo spawning times. Can you explain, do you know what's going on with Ningaloo, how they're spawning on the dropping temperature and GBR's spawning on the rising temperature?
Yes, I'm not going to be able to answer that question, unfortunately, sorry, because I'm specialising in the Great Barrier Reef captive coral synchronisation, so sorry. Maybe there's someone else out there that can help him with that question.
Thank you, Lonnie. Everyone give Lonnie a round of applause.
Thank you.
Great talk.